Hi, this is Halal. In this video on mathematical economics series, we will discuss about the differentiation of the exponential and logarithm functions. The first rule is the natural exponential rule that says given f of x is equal to e to the power g of x, where g of x is differentiable function of x, the derivative is f dash x, means the derivative of this function, that is equal to e to the power g of x times g dash x. This means the derivative of the given function, natural exponential function, is equal to the original function multiplied by the derivative of the exponent, that is the derivative of natural exponential function is equal to the original function times the derivative of exponent, that is f of x is equal to e to the power g of x is our original function. Now its derivative is equal to f dash x, which is equal to the original function, that is this, times the derivative of this exponent. Now we will see an example. Let us say we have f of x is equal to e x square. Now we have to differentiate this exponential function. For that, let g of x is equal to x square. So in place of x square, we have written g of x. Now the derivative of g of x is g dash x. Now the derivative of x square is 2x. Clear? Now the differentiation of this function will be equal to, we will substitute the value of g of x in this equation to get the value the derivative. So the derivative of this function is equal to, that is f dash x is equal to e of g of x times g dash x. That means the derivative of this exponent. Now our original function is, I will write this e of, now g of x is x square, so I will write x square times the g dash x. G dash x is 2x, which is equal to 2x e to the power x square. Now I can write another example. Let's say we have f of x is equal to x square. Now simply we will put, I will write e of x cube. So I will write this g of x. Now I will write g of x is equal to x cube. I will differentiate this, so this will become g dash x is equal to 3x square. Now the differentiation of this will come out, that is f dash x is equal to, now f dash x is equal to g of x, that is e to the power g of x, the original function, times this g dash x. Now we will insert the value. Our original function is e, now g of x is x cube, so I will write x cube times, now the derivative of g dash x, we got that is 3x square, so this will become 3x square e x cube. So we have to remember the derivative of a natural exponential function is equal to the ordinal function. Here that is the ordinal function, this and this, times the derivative of this exponent. Now the second rule is the exponential function rule for base a other than e. Now in previous rule we have the base e, but here we have the other base, that is a, where a is greater than 0 and a should not be equal to 1. Now given f of x is equal to a to the power g of x, where a is greater than 0 and a is not equal to 1, and g of x is differentiable function of x, the derivative is given by, now the derivative of this function is equal to, that is a to the power g of x times g dash x times log of a. That means the derivative of this function is equal to the ordinal function times the derivative of exponent times log of a, log of this. Now we will write another example, or I can say if we have f of x is equal to let us say a to the power 1 minus 2x. Now let g of x is equal to 1 minus 2x. So I will write this as g of x is equal to 1 minus 2x. Now we have to differentiate this, so this means g dash x is equal to, now the derivative of 1 is 0 and derivative of 2 of x is 2, so this will become minus 2. Now the derivative of this function is given as, that is f dash x is equal to, now we have seen it is the ordinal function. Now our ordinal function is, I will write this as we have the a of g of x times the derivative of the exponent times the log of base a, that is a. Now we will insert the values. Here it is a to the power g of x, so here it is a. Now g of x is 1 minus 2x times the derivative of this exponent which we got here, that is minus 2, so I will write minus 2 times log of a, so this will be same here, log of a, so this will become minus 2 log of a times a to the power 1, that is 1 minus 2x. Third rule on the differentiation of exponential and logarithm functions is the natural logarithm function rule, that says given f of x is equal to log of g of x, where g of x is positive differentiable, the derivative is, if we are given a function f of x is equal to log of g of x, the derivative of this function is given by, that is f of x means the f dash x means the derivative of this, that is equal to, now log of g of x is equal to 1 over g of x times the derivative of this denominator, that is g dash x over g of x. Now we will see an example. Let us say we have f of x is equal to log of 6x. Okay, so this is our logarithm function. Now we will put this equal to g of x. Let g of x is equal to 6x square. Therefore g dash x is equal to, now this will become 12x. Now the derivative of this will be, now this is equal to f dash x is equal to, that is given here, that is equal to 1 over g of x times g dash x. Now putting the values of g of x and g dash x, our g of x is 6x square and g dash x is 12x. So this will become 1 over 6x square times 12x. So this is equal to 12x over 6x square. Now this will become 6 1s are 6 2s are, and x square will cancel, 1x. So this will become 2 over x. Therefore f dash x is equal to 2 over x. We can have another example. Let us say we have log of, or we can write as y is equal to log of x. Now we have to differentiate this. First of all, here we have x, so I will write g of x is equal to x. Now the derivative of g dash x is equal to 1. Therefore derivative of this, here we have y, so I will write y dash means the differentiation of this equation, and this function will be equal to, that is equal to 1 over g of x times the derivative of this denominator g of x. So this is 1 over g of x is our x and g dash x is 1. So this is equal to 1 over x, implies y dash is equal to 1 over x. Now the other rule for differentiation of exponential and logarithm functions is logarithm function rule for base a other than e. That is, given f of x is equal to log of g of x with base a, and a greater than 0 and a is not equal to 1, and g of x is positive and differentiable, the derivative is given by, that is, the derivative of this function is given as f dash x is equal to log of g of x is 1 of g of x times the derivative of denominator into log of e to the base a. This is the derivative of this function, logarithm function, where the base is a other than e. So, or we can write this as, this is equal to g of g dash x over g of x, g dash x over g of x into now this log e with base a is equal to 1 over, or I will write in place of this 1 over log of a, because this log of e to the base a is equal to 1 over log of a. So with an example we will see what does this mean. Now let us say f of x is equal to log of a dot 2x square plus 1. So this is our example. First of all, we will write this as g of x. Therefore g of x is equal to 2x square plus 1. Now we have to find the g dash x. So I will write g dash x means the derivative of this function. So this will become 2 2s are 4x. Clear? Now I can write this as f of x means f dash x means the derivative of this function is equal to, that is equal to g dash x over g of x, g dash x over g of x times 1 over log of a. So I will put the values here. Now g dash x is 4 of x, 4x over g of x is 2x square plus 1, and the log of a. So I will write this log of a. So this was the logarithm function rule for base a other than e. Now we have to remember here log of e with base a is equal to 1 over log a, and the rest is very simple. So please subscribe to our YouTube channel Econ Maths for more videos on mathematical economics. Also comment and share. Thank you.